A few weeks ago, I saw several videos made on fire, like Mr. Green Guy putting out metal fires, as well as Tom from Explosions in Fire putting out metal fires with extinguishers using sodium chloride. This indeed got me really curious and interested in fires and heat in general, and on its own, it's nothing but a simple chemical reaction going on. This reaction in particular is called a combustion reaction, and on its own, it's not too special, but for some reason, I thought it might be interesting, and I decided to teach that with a series of reactions. So, today let us discuss about combustion reactions with various examples. Combustion. A combustion reaction is a rapid, high-temperature chemical process where a fuel reacts with oxidant, usually oxygen, to produce heat, light, often as a flame, and oxidize products like carbon dioxide and water, classifying it as an redox and exothermic reaction that requires activation energy to start. It's essentially burning, powering everything from car engines to campfires and essential for generating energy. Or in simple words, where a fuel reacts with oxygen to produce heat that requires a spark. Examples are like including burning fuels like methane in a gas stove. This is quite common, and we use methane to cook food and generate heat in daily life. Types of combustion reactions. There are two types of combustion reactions, that is, complete combustion and incomplete combustion. Complete combustion involves in a reaction in which the fuel reacts with oxygen to make carbon dioxide and water, releasing heat and energy. Incomplete combustion involves a reaction in which the fuel reacts with oxygen to make water, carbon monoxide, and sometimes unburned carbon. To demonstrate this, I indeed needed a fuel, but it was either a liquid or gas. This is because I can't obtain other organic fuels like ethane or propane. Other than that, use just only methane, which is available for cooking in stoves. So I took organic solvents like alcohols. Alcohols are the same thing, but they have an hydroxide functional group attached to the end of their reactive portion of their molecule. So instead using methane, ethane, or propane, I'm using methanol, ethanol, and propanol. Now in this case, I can easily demonstrate how these resemble combustion reaction as a liquid fuel. To do this, I first got a metal dish which will be resistant to high temperatures and prevent it from cracking. So I wore some heat-resistant gloves, and using a pipette, I added some methanol in the dish. Now generally it's not advised because alcohols are highly flammable, but since it's a small amount, it's safe at some point. Now all I have to do is to burn a matchstick and put it in the liquid. Almost immediately it caught fire and the flame started to burn. The reaction going on over here is that the methanol is reacting with oxygen to make carbon dioxide and water. This need only a small spark called the activation energy, which was the match required to ignite the alcohol. In some cases, alcohol also reacts to make carbon monoxide and water, and sometimes making unburned carbon, which is a black residue found on the top of the stoves. This, when burning, produces a nice blue flame until the alcohol runs out. Now with ethanol, it also produces a nice blue flame with a hint of yellow into it. Fires like this are easy to put out by just blocking the oxygen to the fuel. This is why it is widely used in oil lamps or alcohol lamps and using it as lighter fluids. Other fires, like metal fires that I watched myself, were dangerous and notorious to put out, and I might make a video about it in the future. With propanol, I was greeted with a very strong yellow-orange color, and this was one of the most strongest flames. This is not because I used a lot of alcohol, but because it was a much complex molecule having 3 carbons, 8 hydrogens and 1 oxygen. I also used other organic solvents like acetone, and like the propanol, it was also a much strong yellow-orange flame, but not much stronger than propanol, because unlike propanol, it has 3 carbons and 1 oxygen but 6 hydrogens. This was almost combustion reaction in general. Now I want to work on incomplete combustion with a reaction called a pyrolysis reaction. Pyrolysis reaction is a reaction in which the thermal deposition of organic materials like biomass, plastics, or tires into smaller molecules by heating them in the absence of oxygen. But what I am doing is the pyrolysis of some table sugar into a chunk of carbon. So to do this, I added some sugar into a dish and turned up the heat below the stand. A few minutes later, it looked like nothing, but after some time, the sugar was melted. This is because sugar is caramelizing, but after some time, it slowly changed color. And later on, it started producing some sweet smoke. This is because the sugar is dehydrating, and after some time, the sugar was going a carbonization phase. The reaction going on over here is the sugar itself is reacting without oxygen, causing it to break down into simpler compounds like water vapor, carbon dioxide, carbon monoxide, methane, and various organic liquids. Slowly, it got darker and darker, and at some point, it was all done. Now, all I had to do was to remove the heat and let it cool down. When it was cooling, I poked at it, and it was still a bit sticky, which meant that some sugar is still not much carbonized. But anyways, when I cooled it, it was really hard to remove this stuff, but thankfully, the sugar is not much carbonized, so I can easily remove it by just some boiling water into it and dissolve the black sludge into it. Well, this was a small demonstration on how incomplete combustion behaves, and this was all about this process. In future, I plan to make a video on metal fires, but for now, it wouldn't have been possible to do this stuff. Now, this is because such chemical experiments are quite dangerous. In future, I plan to make video on metal fires, but for now, I guess it's not safe. But anyway, I hope you liked this video and learned a lot from it, and I hope to see you in next one. Thanks for watching.